वेलकम स्टुडंट. रयत शिक्षण संस्था सातारा रोज प्रोजेक्ट 2021-22 11 सायन्स conducted by यशवंतराव चव्हाण Institute of Science Satara. Myself Bhagyashree Prakash Ranade from Junior College Mathematics Department. Today I am going to discuss third lecture from the topic set and relation. In previous lecture, we have studied types of set and operations on set. In this lecture, we are going to study next point, and that is types of interval. There are interval means subset of real number. We know that set of real number is a infinite set. That is, it contains infinitely many elements in it. Okay. If we consider two numbers on a set of real line, and if we take all the points in between that two number, then that set is subset of the set of real number, and that set is called as an interval. Okay. There are total 4 types of interval, in which first type is open interval. There are 4 types of interval: open interval, closed interval, semi-closed interval, and semi-open interval. In which first type is open interval. If we take 2 points A and B on real line, then the set X is set of all real numbers which are in between A and B. Here note that here is a condition that A is less than X less than B. A is strictly less than X less than B, and therefore in this set A and B, these 2 points are not belonging in this set. So open interval AB does not contain the points A and B, but contain all the points in between A and B. Okay. Then next type is closed interval. Before that, we see this example. Here is the open interval 3, 5. Where this set contain all real number in between 3 and 5, excluding 3 and 5, not including 3 and 5, excluding 3 and 5. Next type is closed interval. Closed interval is a set of real number which are between A and B, including A and B. That is, A is less than or equal to X, less than or equal to B. In this set, closed interval AB, the points A and B belonging to that set. Okay. And closed interval AB is denoted by inside the square bracket AB separated by commas. For example, see closed interval 2, 5. This is set of all X containing real numbers between 2 and 5. That is 2 less than or equal to X, less than or equal to 5. Next type is semi-closed interval. The set X, set of all X such that X belong to R, A less than or equal to X less than B, is called a semi-closed interval. It is denoted by open square. It is denoted by square bracket A and B, and which is completed by simple bracket. Note that this is semi-closed interval. Semi means half. So here half interval is closed and half interval is open. आता बघा सेमी क्लोज इंटरवल मध्ये अर्धा इंटरवल ओपन असणार आहे आणि अर्धा क्लोज असणार आहे. तर मग क्लोज कोणता असणार आहे, तर लेफ्ट हँड साइडचा पार्ट क्लोज असणार आहे. लक्षात ठेवायचं, सेमी क्लोज मध्ये लेफ्ट हँड साइड क्लोज आणि सेमी ओपन मध्ये लेफ्ट हँड साइड ओपन, असं लक्षात ठेवायचं. त्यामुळे हा इंटरवल कसा असेल बघा, square bracket A, B, simple bracket. Okay. So, for example, -7, -2, semi-closed interval. It is a set of all real numbers in between -7 and -2, including -7. बघा ह्याच्यामध्ये x is -7 is less than or equal to x, म्हणजे x ची व्हॅल्यू -7 असू शकते आणि ती -2 पेक्षा लहान असायला हवी. ओके. So this is semi-closed interval. Then next type is semi-open interval. The set x such that x belong to R, a less than x less than or equal to b is called a semi-open interval. It is denoted by open a, close b. आता इथे बघा सेमी ओपन मध्ये पहिला लेफ्ट हँड साइडचा ब्रॅकेट ओपन असतो म्हणजे सिंपल ब्रॅकेट असतो आणि राईट हँड साइडचा ब्रॅकेट हा स्क्वेअर ब्रॅकेट असतो. बरोबर. So set of all x belong to R. Here in this set, the set containing B but not A. Okay. For example, बघा semi-open interval 2, 5 is a set of all real numbers in between 2 and 5, including 5 but not 2. Okay. So these all are types of intervals. Now we see next point, and that is De Morgan's law. De Morgan's law, these are two laws which are related with union and intersection of two sets. We have in previous lecture we have studied three operations on set, that is complement, union, intersection, and also we have studied different. Okay. Among that, complement, union, and intersection, these are main operations. And this De Morgan's law, there are two laws which are related with complement, union, and intersection. And the law states that the complement of the union of two sets is the intersection of their complement, and the complement of the intersection of two sets is the union of their complement. These are De Morgan's law, and symbolically they are denoted as A union B complement is equal to A complement intersection B complement, and A intersection B complement is equal to A complement union B complement. These are called as De Morgan's law. We are going to study the De Morgan's law for solving the examples. Now here is the proof of De Morgan's law by Venn diagram. If you observe these two diagrams, then first diagram is of first law, that is A intersection B complement, which is shaded by green color. Okay, is equal to A complement union B complement. For both sides, the diagram is first diagram. Okay, and second diagram indicates second law. A union B complement is equal to A complement intersection B complement. So this is proof of De Morgan's law by Venn diagram. Then there are some important formulae related with cardinality of the union and intersection set. Cardinality means number of elements of a set. So main law is n of A union B is equal to n of A plus n of B minus n of A intersection B. This is main law. Then if A and B are disjoint set, then their intersection is empty set and n of A intersection B is 0. So if A and B are disjoint set, we can say that n of A union B is equal to n of A plus n of B. Then next law is n of A intersection B. Now this is conversion of first law. बघा पहिला जो लॉ आपण इथे स्टेट केलाय, n of A union B is equal to n of A plus n of B minus n of A intersection B. त्यातला राईट हँड साइड मधला मायनस n of A intersection B जर मी लेफ्ट हँड साइडला आणला तर तो पॉझिटिव्ह होणार आहे. आणि इकडचा लेफ्ट हँड साइडचा एन ऑफ ए युनियन बी राईट हँड साइडला नेला तर तो निगेटिव्ह होणार आहे. त्यामुळे थर्ड लॉ म्हणजेच काय आहे तर तो फर्स्ट लॉचच कन्व्हर्जन आपण केलेलं आहे. एन ऑफ ए इंटरसेक्शन बी इज इक्वल टू एन ऑफ ए प्लस एन ऑफ बी मायनस एन ऑफ ए युनियन बी. ओके, तसंच एन ऑफ ए आणि एन ऑफ बी यासाठी सुद्धा आपण त्याचप्रमाणे पहिला जो लॉ आहे त्याच्यामध्ये राईट हँड साइडला फक्त एन ऑफ ए आहे तसाच ठेवून आपण काय केलेलं आहे, एन ऑफ ए युनियन बी प्लस एन ऑफ ए इंटरसेक्शन बी मायनस एन ऑफ बी असं कन्व्हर्जन त्याचं केलेलं आहे. आणि एन ऑफ बी इज इक्वल टू एन ऑफ ए युनियन बी प्लस एन ऑफ ए इंटरसेक्शन बी मायनस एन ऑफ ए असं त्याचं कन्व्हर्जन केलेलं आहे. Now we see some examples. First example is, let A and B be two finite sets such that n of A is equal to 20, n of B is equal to 28, and n of A union B is equal to 36. Find n of A intersection B. Now we use here law of cardinality. Using the formula, n of A union B is equal to n of A plus n of B minus n of A intersection B. So by putting all the values, we get n of A intersection B is equal to 48 minus 36 is equal to 12. सगळ्या व्हॅल्यू आपण पुट केलेल्या आहेत दिलेल्या फॉर्म्युलांमध्ये आणि त्याची n of A intersection B ची व्हॅल्यू आपण फाइंड आउट केलेली आहे. बघा नेक्स्ट एक्झाम्पल, if n of A minus B is equal to 18, comma n of A union B is equal to 70 and n of A intersection B is equal to 25, then find n of B. Now here note that n of A minus B means n of A intersection B complement. Okay, and here is a formula related with difference of the set and union intersection, and that formula is n of A union B is equal to n of A minus B plus n of A intersection B plus n of B minus A. आता हा जो फॉर्म्युला आहे हा खरोखर असा आहे का, तर हे जर तुम्हाला व्हेरीफाय करायचं असेल तर तुम्ही व्हेन डायग्राम काढून बघू शकता. इट इज it will be clear that from Venn diagram that n of A union B is equal to n of A minus B plus n of A intersection B plus n of B minus A. Okay, आता ह्याच्यामध्ये आपण दिलेल्या सगळ्या व्हॅल्यू पुट केल्यात. By putting all the values of n of A union B, n of A minus B, n of A intersection B, we will find out value of n of B minus A. Now we get n of B minus A is equal to 27, but we have to find out value of n of B. Okay, and so n of B is equal to n of A intersection B plus n of B minus A, and therefore n of B is equal to 25 plus 27, and therefore n of B is equal to 52. Okay, so in this way we have solved this problem. Then next example, in a group of 60 people, 27 like cold drink and 42 like hot drink, and each person like at least one of two drinks. How many like both cold drink and hot drink? Now see, आता बघा इथे आपल्याला काय दिलंय, 60 पीपलच्या ग्रुपमध्ये 27 लोकांना कोल्ड ड्रिंक आवडतं, 42 ना हॉट ड्रिंक आवडतं, आणि प्रत्येक व्यक्तीला एकतरी काहीतरी घ्यायला आवडतच. ओके, म्हणजे अशी एकही व्यक्ती नाही की जिला कोल्ड ड्रिंक हॉट ड्रिंक काहीही आवडत नाही. मग आता आपण पहिल्यांदा दिलेल्या गोष्टी आहेत त्या सेटच्या फॉर्मॅट मध्ये लिहून घेऊया. लेट ए बी सेट ऑफ ऑल पीपल हू लाईक कोल्ड ड्रिंक. Let B be the set of all people who like hot drink. Therefore, n of A union B is equal to 60, n of A is equal to 27, and n of B is equal to 42. Now, here every person has at least likes at least one drink means their intersection is non-empty. Okay, and therefore we have to find out the value of n of A intersection B. So by the formula, n of A intersection B is equal to n of A plus n of B minus n of A union B. And so the answer is 9. And therefore 9 people like both cold drink and hot drink. Okay. So this is third problem. And then last problem from this lecture. Each student in a class of 40 play at least one indoor game chess, carom and Scrabble. 18 play chess, 20 play Scrabble and 27 play carom. 7 play chess and Scrabble, 12 play Scrabble and carom and 4 play chess, only chess. Sorry, 4 play chess, carom and Scrabble. Find the number of students who play chess and carom but not Scrabble. आता इथे काय काय दिलंय बघा. एका 40 स्टुडंट असलेल्या क्लासमध्ये इंडोर गेम खेळणारी मुलं आहेत. त्याच्यामध्ये इंडोर गेम कोणकोणते आहेत तर चेस, कॅरम आणि स्क्रेबल. त्याच्यामध्ये 18 स्टुडंट प्ले चेस, 20 स्टुडंट प्ले स्क्रेबल and 27 student play carom. 7 play chess and Scrabble. Means what? They lie in intersection of chess and Scrabble. Okay. 12 play Scrabble and carom. And 4 play chess, carom and Scrabble. Now we have to find out number of students who play chess and carom. And secondly chess, carom but not Scrabble. आता आपण पहिल्यांदा काय करायचं तर दिलेल्या गोष्टींवरून दिलेल्या इन्फॉर्मेशन वरून प्रत्येक गेम साठी आपण एक सेट अज्युम करूया. ओके. सो लेट A be the set of student who plays chess, B be the set of student who plays Scrabble and C be the set of student who play carom. मग आता आपण सगळ्या दिलेल्या गोष्टी लिहून घेऊया. इथे टोटल सगळ्या तिन्ही सेटचं युनियन काय असणार आहे तर टोटल नंबर ऑफ स्टुडंट इन अ क्लास म्हणजे 40. n of A is equal to 18, n of B is 20, n of C 27, then n of A intersection B 7, C intersection B 12, A intersection B intersection C is equal to 4. आता इथे आपण 3 सेट साठीचा जो फॉर्म्युला आहे आपल्याकडे म्हणजे एक्सटेंडेड फॉर्म्युला तो वापरणार आहोत. We have the formula, extended formula, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Now we put all the values, all the given values, and therefore we will get n of C intersection A. By doing calculation, we get n of C intersection A is equal to 10. Okay. आता n of C intersection A म्हणजे काय? This is number of students who playing chess and carom. Okay, chess and carom. Now, secondly, also the number of students who play chess and carom and not Scrabble is equal to n of C intersection A minus n of A intersection B intersection C. So that number is 6. Okay. So in this way, today in this lecture, we have studied types of interval, De Morgan's law, then laws of cardinality, and all the examples based on the on this laws of De Morgan's law and laws of cardinality. Okay. So thank you.